Hello guys, welcome to my channel once again. So today we'll be talking about the borrow checker, Ross's borrows checker. This is a very fundamental part of Rust. It's what makes Rust what it is, what makes it special, what gives it that capability to help programmers write better, safer code. So I know the borrow checker is not a new thing. Whether you're starting Rust or you are a senior Rust programmer, it's not a new term. So we are going to be talking about it in depth. Now, from my experience, Rust is not easy. Even when you're coming from a different programming language, because of the mental shift, because of the new things you are going to get used to. So it might take a while, but it is not as easy as some people describe it. So for a beginner, it can be a little bit easier because there's not much of a mental shift from maybe a previous programming language like Python or whichever programming language you're coming from. But let's go back to the video. The borrow checker is a core part of Rust that every Rust programmer needs to know in and out. So we are going to be looking at what the borrow checker is, what it does, how it does it, why, and a lot of other questions. So this is going to be a long video, but it's going to help you understand the borrow checker as much as possible. So next time you're writing code, you will know when you're going to have an issue with the borrow checker. Instead of fighting it, you work with it, and the Rust compiler is very helpful with its error messages and hints. So we are going to go straight into the business of the day. So Rust's borrow checker has a rule that guides everything about programming in Rust, especially during compile time and even during runtime when you are using maybe a smart pointer where the borrow checker works during runtime, but that's a different topic. So we are dealing with compile time checks. So the rule is very straightforward. So let me move up. It says at any moment for a given piece of data, you can have either any number of shared or read-only borrows or exactly one mutable borrow, that's an exclusive or write borrow, but never both at the same time. So at any given moment for any given piece of data, you can either have one of these multiple borrows or mutable borrows. So let's think of it like a library book. A shared borrow, the ampersand T, that's a reference to a type It's like everyone can come and read this book at the same table. No one is stopping anyone from reading it. Multiple people can be reading a book at the same time. Now, the ampersand mut t is a mutable borrow, an exclusive right borrow. So this is where one person is making changes to the book, maybe scribbling on the edges or the margins, or writing into the book, just making changes into the book. Now, at that point, while somebody is making changes, no other person is permitted to be reading the book or accessing the book. As long as one person is making changes, no other access is permitted or allowed. But if one person is reading the book, just looking at it, any other person, any other number of persons can also be reading the book. So multiple people can be looking at or accessing a data, but only one person can change it at a time. So where does this rule become an issue? It is where there is a modifier and there is a reader. So a group of people or one person is reading a text, and someone else is trying to write into the text. This is where the borrow checker comes in. Oh, you are doing something wrong. I have to stop you. This is not allowed. You're breaking the rules of Rust. It's as simple as that. One thing at a time. So what is that time? Now, we are going to be writing some short codes and work together with the code, know why it doesn't compile. I am not using an IDE here, so we don't get to see where the issues are coming from until we run the program. But before running the program, we'll talk about why it won't compile, or why it will compile, or if it will compile or not. Okay, so now going back to let's write some code. So select a equal to 5. So we're going to print a. Let's print a here. I think this should be here. It's important. So you'll be seeing the rule as we move along. So here, now we have created a variable that owns an I32 value. So here we are using our variable, we are accessing it. So it was created on line 11. We are accessing it on line 13. We can move it. So we are accessing it on line 12. Now let's run this code. So now, after creation, there is utilization. Now, what is the meaning of this utilization? So a use, okay, I think I need to add something here. Let's excuse me, let's b equal to, so this is going to be b. Let's run this. Now this is not a borrow, this is an owned variable value. A owns it. The borrow checker has no business with this. Now the only time you have the borrow checker doing something is when there is an ampersand or there is same ampersand with a mute. That's when the borrow checker comes in. So there is a borrow here, just reading. There's a borrow here, but with write access or write permission. Now this is where there is a borrow, and we are using this reference. B is referencing or accessing the data in A. So we are using B here. So what is a use or usage here? A borrow's usage doesn't mean modifying. It means at any point where the reference is actually accessed to reach the underlying data, whether that data is read, like printing it like we just did, or written, like modified. Either read or modified, that's a use. So a reference like this needs to be used or not, depending on what you're trying to do. So let me clear this up. Now let me make a space here. So there is something called a window, like an opening. So this is a window. Line 12 is a window where B has been created. Now B's window stays open till its last use. So the last point where B was used is this on line 17. So from 12 to 17, B's window is open. Let's say we don't have this here. That means B's window opens on line 12 and closes. This window opens and closes immediately where it was created because it was not used. But if we add our print here, there's a usage. So the window starts from 12 and goes all the way to 14. Now we're not talking about a value being dropped. No, this is a different thing. I think it's called NL, Non-Lexical Lifetimes, or stuff like that. Cannot remember the terminology, but what I am trying to say is there is always a window. Once we start having examples, it will be clearer. So Like we said before, at any point for any given piece of data, you can either have one person modifying the data or multiple people reading the data, just looking at the data. No write access. When both of them happen at the same time, that's where there's going to be a problem and your code is not going to compile. You're going to see an error and a hint on why there's the problem. Okay, now let's have an example. We're going to write a simple code. So we say let mute. I'm going to explain something important here. Call to 5. So let's create a reference to X, a borrow. So we call it let's reference 1 equal to a borrow of X. Let reference 2 equal to borrow of X as well. Now let's use this. So we're going to be looking at our value arrow1 and arrow2. Now this is not a borrow. This is a variable, a mutable variable. So this variable X has a binding mute. So there's no borrow, it's just a value that is allowed to change. We can change it later. That's why we have a mute here. So wherever you see the ampersand or ampersand mute like this, then that's a mutable borrow, but just the ampersand is a regular borrow. So this is clear. There's no borrow here. It's a mutable variable that owns 5, which is an i32 value. So now this is a shared borrow. More than one person is looking at this, is referencing this, is borrowing this. So this is a shared borrow of X, shared borrow 1. This is shared borrow 2. Now the window of R1 starts from 13 up until 16. The window of R2 starts from 14 up until 16. Now looking at this code, is this going to compile? Let's look at the rules. Multiple people can be looking at the same data, reading the same data. There won't be any issue. Now looking at this code, is there any point where someone else is modifying the data? No. This data, the arrow 1, which is a borrow, the arrow 2, which is a borrow, they all get used at line 16. So we're going to run this code and see what it does, if there's going to be an error or not. Now we're going to skip this. It's just saying we do not need the mute because we did not actually use it. So if you look at the output, we have 5, 5, which is correct because these are all referencing to x. So if you change x to 50 and run the program again, we are going to get 50, 50. So arrow 1 is pointing to x, arrow 2 is pointing to x. None of them are making any change. So let me sit upright and we'll continue. So now let's clear this. I know we explained some things and these are going to be clear enough. Now let's try something else. So let's say let mute x equal 5. Let arrow 1 equal reference to x. Let's print. I'm used to the IDE bringing some of these stuffs. So let's print x, not x, the reference, which is arrow 1. Oh, sorry. Then let's create another reference, arrow 2 equal to mute. It's going to be mute x, right? Yes. And let's print arrow 2. Oh, this is, why didn't I see that? I've not used this. I think I've been using the IDE directly, so pardon. Now looking at this code, like we said, this is a variable, a mutable variable. It's not a borrow, it's not a reference or whatever. It's a variable with a mutable capability. This is where we create a reference or a borrow to this value or this variable. Now we use it here, as you can see, arrow 1. Now we create another reference but with a mute. So this is a reference with write access. Here we use the reference. So looking at this code, are we breaking any of the borrow checkers rule? Is this code going to compile? You can look at the code yourself and determine if it's going to compile or not. But let's go through the code. Here is where we create our variable. We don't have a problem with that. The borrow checker doesn't have a problem with that. Now we have created a reference. Someone is looking at the data. From line 13, arrow 1's windows is alive or open up to line 14. So there's a creation, there's a usage. Okay, now going to line 16, arrow 2 is created. It can write to the data, not just read. Then at line 17, arrow 2 is used. Now the issue is if there is a read and write. Now it doesn't matter the point of creation. The only place you have an issue with the borrow checker is when a read and right overlap. So looking at this, is it going to compile or not? I, looking at this, believe this code should compile. Why? Because we are not breaking the rule anywhere. So while this is open, it closes here, then somebody else just takes the book and starts writing. After writing, he looks at what he has written. So let's change this number to 10 and see what happens. So we are supposed to have 10 here, good, and 10 here. So this is correct. So if you want to make any change to the values, reference, or whatever, you can do those here. Okay, but now this is, I think, example 2, because we have tried a simpler one. Now let's try something else. We're going to clear this again and write some new code. So let mut x equal 5. Let arrow 1 equal a reference to x. Let arrow 2 equal a mutable reference to x as well. Print y, I don't know, it should have come out. Print arrow 2 print, okay, now it came out. Print arrow 1. Now once again, we need to ask ourselves, is this code going to compile? Are we breaking any of the borrow checkers rule? The rule is right here, so you can always look at it. Now we have a variable as usual with a mute keyword, because we can change this variable later. Okay, but we did not change it here. So on line 13, we have arrow 1, which is a reference, an immutable reference. I think I need to be using that word. So this is an immutable reference to x. Okay, on line 14, we have a mutable reference, ampersand mute to x, a mutable reference to x. On line 16, we print the reference to x from arrow 2. On line 17, we print arrow 1. Now, is this code going to compile or not? It's not going to compile because the rule is being broken here, and I'm going to explain something. So on line 13, let's use a real world scenario. On line 13, Mr. R1, okay, let's call this a hotel. Let's call this a hotel. Let's call it a hotel. So I don't want to mention any hotel name, so let's call it a hotel. On line 13, Mr. R1 checks into a hotel and gets a room. So just like in real life, if you check into a room from Monday to Sunday, you have access to that room. It's all yours from that from the period you checked in to the period you check out. So checking out, is when you are done using the room. So arrow 1 is checking out here. Okay, so let's say we don't have this. Let me comment this. So arrow 1 checks into the hotel. Oops, he doesn't like it. He goes away. It does not stay any longer. That's the window thing we were talking about. Let's uncomment this. So arrow 1 checks in and stays from day 13 to day 17. Now, why is the rule broken here? While arrow 1 is checked in, arrow 2 is also checked in. So arrow 1 checked in from 13 to 17. While he is checked in, someone else comes in, not just to look at the sign on the room, the number, but going into the room and scattering the room because he has right access. This is an overlap. So the shared borrow of arrow 1 here is overlapping with the mutable borrow of arrow 2. Now, if arrow 1 checked out before arrow 2, there isn't going to be an overlap. But here, arrow 2 checked in, used the reference it has, while arrow 1's window is still open, because you see arrow 1's window starts from line 13 up until line 17. But in between, this is where the overlap happens. Here, in between, this is where the overlap happens. Now, if we run this code, you're going to see that there will be an error. So the error says cannot borrow X as mutable because it is also borrowed as immutable. You cannot check into this room while somebody is still there, while somebody is still using it. Multiple people can be reading the data, but not reading and writing at the same time. That's where the rule is broken. You can be writing, once you're done, another person can be reading, but not reading and writing at the same time. So if you look at the code again, it's the compiler points you to where the issue is coming from. This is where the immutable borrow reference occurs. This is where the mutable borrow occurs. So this is, like I said, this is where the overlap happens here. Okay, now R1 is alive up till here. As you can see, mutable borrow later used here. Like we explained before, use is when you read the underlying data or access it, whether reading it or modifying it. It's a usage. So R1 was later used on line 17. So the borrow checkers rule was now broken. Now we're going to look at another code, and we try to question ourselves and know if it's going to compile or not. But I think this is clear enough. So let's type something else. Excuse me. So we're going to be doing a lot of x. Let's make x equal to 5. Let's arrow1 equal to reference to x. So let's print arrow1. Let arrow2 equal to reference to x. Mutable reference to x, because we want to cause problems. I think I can just use the print without the print line, so no need for the next line thing. But well, I'm used to the next line print. So this is another piece of code, and we are going to be looking at it again. Do you think this is going to compile? So looking at the code again, we have a variable created here, we have a reference here, and this reference window starts from 14, then gets used at 15, gets used again at line 20. So there is a break in usage. So the first usage here, second usage here, so this is the last usage. But let's see if we can find an overlap where this rule is broken. So while arrow1's windows is open, arrow1 is being used, this is good. Okay, so line 17, a mutable reference is created, and then that reference is used. So the last line is we accessing the reference that was created here. Now the overlap that we are going to have is going to be because of arrow 1. So we are trying to modify a data that is already been. So let's say arrow 1 here is an address to a building somewhere in an estate, and you look at the address here and say, oh, this is number 50 blah 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 house in the estate. Then somebody comes in and makes a change to the address. There's no change right now, but I just want to explain something. Somebody comes in and makes a change to the address while you still have this. The person uses it. Now there is a possibility that this is what Ross is trying to avoid. There's a possibility that this has changed. What if this was changed by this person? So instead of pointing to maybe number 50, it has changed to a different number. There is going to be inconsistency. So what you thought you had would have been changed behind the scene. So this would not compile, because while it has been used clearly at the top without any issues, there is now someone with a mutable access and then the previous reference is now being used again. This is where the overlap happens on line 17. This is where the overlap happens, and 20. So because you are trying to use this reference again when there is a mutable access to that same data. The data we're talking about, the piece of data we're talking about is X. So let's try to run this and see what happens. Now you can see cannot borrow X as mutable borrow because it is also borrowed as immutable. So where is the issue coming from? Line 17 and line 20. So this is the first immutable borrow occurs here, and this is immutable borrow later used here. Yes, okay, this is the mutable borrow, the R2, reference 2. So let's say we comment this and run it. It should compile because there is no overlap. As you can see, there's no overlap. This address is read, is used, someone else comes in, and it's just almost the same thing with what we did before, but just not following the exact order. So we're going to remove this and type a different code and see what happens. So let's say let's mute. I'm going to be using a lot of X equal to 5, and let R1 equal to reference to X. Let R2 equal to immutable reference to X. Print. I think I should be using this print. Okay. Yes, R2. Yes, we have R2. So once again, is this going to compile? I don't know. Let's check. So line 12, we created a variable with mute with a mutable binding. On line 13, we have a reference to the variable or the piece of data. So on line 14, there is another reference but with a mutable capability. On line 15, R2 is now used. So looking at this code, is there an overlap somewhere? So this looks simple, or might look simple because of the length of the code, but when you start writing longer code, you'll see the beauty of the borrow checker. But understanding this is the foundation of everything. So line 13, we have a reference to X. Arrow 1 Windows is open here, and there's no last use. So once it opens here, it closes here. It checks into the hotel. It doesn't like it. It goes out. Not like it is dropped. Okay, not like it is dropped. So after the window closes, another window opens for R2, and R2 is used here. So there was no point in time where there is a reference, a borrowed reference, and a mutable reference. So this code should compile. you can look at it yourself. Maybe pause the video, try to read the code and think about what the compiler would do without running the code. So let's run the code and see. So it worked because there was no break of law and order. The borrow checkers law and order. So let's quickly look at another example. So this is going to be maybe something a little bit complex. Not complex, but different from what we have been doing. Let's mute x equal to 5. Let's we have to create a function here. Function means add 1. What does it take? It takes n, which is a mutable reference to an iterator 2. What does it do? So we are dereferencing n here to get the underlying value, and then modifying it. So this does not return anything, just does something. So we can call the function here and pass it a value x. Okay, now we do the print. So what are we printing? R1. Yup. So now you can pause the video to know if this will compile or not before we walk through it. So walking through it, we create a variable on line 12 x with the mute keyword. On line 13 we have a reference. Now where is this reference? What's the last use of this reference? 17. Okay, so in between the window of the reference and the last use, where the window closes, is there an overlap? That's the one question. As you can see, this function takes a mutable reference to the value that is passed to it and does some magic. So here the function is called, and what does it do? It has a mutable reference to x here, and then it is arrow 1 is now used here. Okay, so in this case this is not going to compile, because while arrow 1's window is open, there is a mutable access to the underlying value. So let's run this program and see for ourselves. Let me be sure. Okay, cannot borrow x as mutable because it is also borrowed as immutable. So arrow 1 is created, the reference. So this is where the mutable borrow occurs, and immutable borrow later used here. So to fix this, we need to make sure the rule is not broken. That's it. We need to make sure the rule is not broken. So this needs to be reorganized. You can try to fix it yourself. See how to do it. Think of how you can do this without breaking the law. We're just going to be running through some examples. So the video is not very long. I know it's already long, but we just want to look at different things and understand what is happening. So I'm going to clear this as well as this, and then write a new code. So this is going to be different. Let's mute let's create a vector. And put 1, 2, 3 inside of it. Okay, let's first equal. So first is a reference to v. A reference to v like a slice. The reference to the item at index 0. So v dot push. So we are adding 4 to the vector. So here we want to see the first. So why do you think this is going to compile, or why do you think it won't compile? Now we have created a variable as always. This is a reference to the data in that vector, the data on index 1. So index 1, index 0, actually 1. So this is 1, 0, 1, 2. Indexing starts from 0. I know we all know that. So this is the window for the reference. Where is it used? This is the last use. First, okay? So this is where the overlap happens. And this is an overlap because we are trying to modify the underlying data. Modify an underlying data while someone is looking at the data. But why is it an issue according to the borrow checker? Why is this a problem? So the vector stores elements in a heap allocation. This vector, right? So if push needs more room than is currently allocated, because this already has a length and capacity, but now we are trying to expand this. So in this case, yes, it needs more room than it's currently allocated. So what happens? What does first do? It allocates a new bigger chunk of memory elsewhere, then copies all existing elements into it, all of this, then frees the old allocation. Now, after freeing the allocation, it now copies, like I said, it copies into a new allocation. So first points to index 0 of the old chunk. In this case, first, okay, after the push, first points to index 0 of the old chunk. If that chunk gets freed, first becomes a dangling pointer. This isn't just a stale value. It's it's like the popular use after free undefined behavior bug. So the borrow checker is trying to stop us from making this issue in the first place. So it doesn't want you to point to something that might no longer be there, has been changed or moved. That's what the dangling is all about. So if you run this again, you see that why is it taking forever to run? Could it be an issue? Okay, so immutable borrow occurs here. That's first. Mutable borrow occurs here. So the push method from this vector actually needs a mutable access to the data. So if you look at the signature and everything, it needs a mutable reference to the data, so it's going to be able to make changes. So this is not going to compile, okay? But if we comment this, so there's no overlap, you can actually see this data because there's nobody making any change to it. So let's see if it's going to work. Yup. So 1, exactly, index 0, 1. So let's quickly look at something else. Very important. So I'm just going to paste, think, struct, call it point. So the main temp. Put a comma here. RX. So quickly looking at this, is this going to compile or not? I know you remember the rules. 1 mutable borrow or multiple immutable borrow. Either of them, not both of them, happen at the same time. So looking at this, we have a struct template here, points, has a field x holds I32, y I32. Now in our main, we create an instance. The point here is P, the X field is holding 1, the Y field is 2. Now, arrow X is a reference to the point, it's a mutable reference to this inside of the struct. Arrow Y is a mutable reference to this field inside of the struct. So arrow X window is here, starts here, opens here, and then the mutable access we have is now used here because we do reference it and add 10 to it. Same thing with arrow Y, the reference add 10 to it, then we now use it here. So this is a use, this is also use. So we are accessing the underlying data, making changes here. We are reading the data, so both of them are all uses. Okay, so now is this going to compile? You can pause the video, look at it, and try to understand what happens. So why does this compile or not? So there's something very important. Sorry, I had to pause to check my phone. There's something very important that's happening here that we need to take note of. So arrow of X is not, so there's the compiler here checks, the borrow checker here checks this structs field per field, not like the entire struct directly, to know if there is a break of its rules. Okay, so arrow of X, sorry, not arrow of X, arrow X has a mutable reference to, remember, at any point for a given piece of data. So this is a piece of data. At this point, this window on line 22, arrow X has a mutable reference to this field. Now, is there any reference to this field at this point? No. Now, arrow Y has a mutable reference to this field. Looking at our code, is there any reference to this field? Maybe a value reading this field? No. So we keep going down. Now arrow X window is still open up until here. Arrow Y window is still open up until here as well. So on line 25, we are dereferencing arrow X to get the underlying value, not just the reference, to get its value itself. So we manipulate it. Now we update it to 10. Okay, line 26, we dereference the RY to get 2, then we update it with 10, not 2, we update it to 10. So just like 10 plus 1, 10 plus 2. Okay, so now there is no combination of a reference and a mutable reference. Now on line 28, we now use our references. So arrow X here, arrow Y here. So looking at the code again, like I said, this is a piece of data. If, for example, okay, we're going to run this code, it's going to compile. I think there is a mistake somewhere. Okay, y passing struct x I32. Look at, oh sorry, this is, yup. You see why Rust is good? See, just went and showed me the issue. Struct point. Okay, let's see if there's anything. Where is this? Line 20. Let's point. Oops. Okay. Good. Because I'm not using an ID, some of these things I don't just see them immediately. So you can see 10 plus 1, 11, 10 plus 2, 12. So this works. So if there is no overlap between the opening window of RX till it's close and the opening window of RY till its closing point. So let's say RY is okay, it's a reference to p.y, right? So we're going to comment this. So now arrowx has a mutable, p.x. arrowx has a mutable reference to this piece of data. Then while it does that, RY is reading this piece of data. On line 25, arrow X modifies the data, and here they are both used. So looking at this case, is there an overlap? Of course, there's an overlap because same piece of data is getting read and modified. Let's run the code and see what happens. You can see mutable borrow occurs here, immutable borrow occurs here. But if we are just looking at p.y, this is a different piece of data, this is a different piece of data. So arrow X is being modified here. Here we are just looking at py. So let's run this and see. You can see there's no overlap. One data is getting something different, the other data is getting something different. So no overlap. But if we uncomment this, this is mute like we did before, there's no overlap as well because we are touching different datas. So it's not looking at the struct as a whole, but the data. That's why when we change this to p.x, we had we had issues. So we're going to try something else. I think we need to leave this struct here and then add something here. I want to implement points. So we want to add a method. Borrow x. So this takes mutable reference to self. So it's going to return mutable reference to an iterators. So inside of the function, we should have mut self dot the x field, because this is mut x. So we have this set up. So in our main, we are going to create a point. We have done that. Then rx is going to be p dot borrow mut x. So we're going to call the function here. Then ry is still going to be that. Make changes here. Rx then okay, we are good. So the point is let me make this. Now we have a different thing going on. So here everything is fine, there's no borrow at all. So the borrow checker does jobs where there's a borrow. So let's x equal p dot borrow mut x. Now what does this function do? Looking at the function signature, it takes a mutable reference to self. Self here is p. Self here is p. So what does it return? It returns a mutable reference to an iterators. As you can see in the body, mutable reference to x. Self is the instance. So this arrow of x, why am I calling it arrow of x? This arrow x is a mutable reference to this field. Okay, so arrow x holds a mutable reference to x from our struct. Arrow y holds a mutable reference to p dot y. Now when we go down, we make a change here. We update the value. Next we update the value. So you're going to look at this code and pause, think, why is this going to compile? Why is this not going to compile? So compared to the previous code, now self here is not just borrowing the field like we saw before. Self is not just borrowing the field. This is the entire struct. So rx has a mutable reference to the struct itself, not just the field in the method body. It's not just touching the field. Note that, like the previous code we wrote. So why this has a mutable reference to the entire struct, arrow y also has a mutable reference to one of its field. So the entire struct, somebody's making changes, another person is making, so this is where the overlap happens. Now we're going to run this code and see why it won't compile from the compiler's perspective. So arrow x, first mutable borrow occurs here, second mutable borrow occurs here. Now first borrow later used here. So this is the reason why it cannot borrow p.y as mutable more than once at a time. So like I said, the ampersand mute self borrows the entire struct, not just the field in the method body. The compiler treats a function or method call as opaque. It doesn't look inside to verify only one field was used. The function signature or contract is very important. That's where the compiler looks. I think I read this somewhere and I just remembered. So this is very important. It doesn't just look at what is here. It focuses on this, and it's now from this contract, it has mutable access to the entire struct. So in the main function, there's a break of the borrow checkers rules. So let's try something else with the same struct. So we have our struct already. Let's change this function to something else. So function, so get x. So this returns 932. Okay. So function this returns self dot x. So that's what this returns. Then in our main we have point setup. Now we need to call the function. We use rx, call it p.getx. So that's fine. Then arrow of y, submits to p.y. Okay, let's remove this. So we just have the print. So okay. Now if you look at this, we want to know why it compiles or why it does not compile. You can pause the video again and look at the code, or we go through together. So we have a function, a method here that takes a mutable reference to the caller. It returns an owned i32. So remember what we said, this is where the compiler focuses on. So the body returns self.x, so it matches this. Now in our main we have p setup as a point. This is not the borrow checker's issue. Now we have rx here that calls the function p.getx. Now what is p.getx here? So p.getx temporarily has a mutable reference to this struct, and immediately this function is called, this line. What rx now becomes is no longer a reference to this struct because of this. So rx here is now an own variable. It owns an i32 value, which is 1. Yup, which is 1. So this is not a reference to anything here. This is where the temporal reference happened. Okay, this is where the temporal reference happened. And then the next line we have is a mutable reference to one of its field, this y. Looking at the other part of the code, this window opens and is last used here. This opens and is last used here. So looking at the code, we don't have any there was no point where a mutable reference and an immutable reference overlapped. There was no point. You can pause the video and look at the code unless I'm making a mistake, but when we run it, we'll now see if there's an error or not. Okay, as you can see, there is no error. So there was no overlap. Mutable and immutable references did not overlap. Always note the window when a variable is, when a reference is created and when it's used. The last use is where the window closes. Where it's created is where the window opens. So this is where the window opens for rx, and this is where it closes because this is where it's last used. Same thing for ry. It opens 28. So if, for example, we say let's roz equal to a reference to ry, a reference to, okay, or let's say a reference to p.y. We don't use it at any point, but here ry is having a mutable reference to this field, this piece of data, and then here roz is reading that piece of data, then here ry is being used. So I think there is an overlap here. but to be sure, let's run the code. Okay, we have an error. Cannot borrow p dot y as immutable because it's also borrowed as mutable. So looking at the code, we can see this is where the error happens, because there is an overlap. It doesn't matter the position. It's about the usage, where one is created, where it's used. Between those windows, what happens? Is there a borrow only or a mutable borrow only, or both of them are happening at the same place, causing an overlap? That's where the error happens. So let me do one. This should be a familiar example, because we're going to be working with the loop. So let's explain. Let's mute v equal to vector, put 1, 2, 3, 4 here. So we're going to do some looping. So for x in v, what do you want to happen? V dot push So looking at this code, I think you might just say, oh, it's not going to compile, but why? Or why would it compile? So here we have a variable that owns a vector of i32 values. So v is created here. So this is not a reference. We don't have any issue with this. So this loop from line 16 to 18 is where something important happens that we'll learn regarding the borrow checker and how its rules can be broken or not. So x, because of this ampersand to v, each of the iterations, x is a reference to v, right? I know this is clear already, how a for loop works. So this is an iterator. It does not own the items, it's just a reference, a view. Now, while this is going on, each of the iteration, while the values are being read, just reference to v is still trying to modify the value. Remember, push is getting mutable reference. That's why we are dereferencing x here. So this looks like an infinite loop, because for each value it's reading here, it's still pushing the same value to the vector continuously. So this is going to obviously not compile, but you understand the reason, because there's an overlap. There's an overlap of one, the data being read, because remember, for the first iteration, this is where it is. While it's reading this data, it's still trying to modify this piece of data, v. This piece of data, v itself, is trying to modify itself while it's reading it. So there's an overlap, and that is where we get the compiler error. So as you can see, immutable borrow occurs here. Okay, immutable borrow later used here. The borrow occurs here. It is still later used here. Then mutable borrow occurs here. That's an overlap. Okay, and we have seen that it will not compile. So if we maybe try something else, we're still going to have this vector. Then we do, let me remove this. We do let's mute new items equal to going to vector a new one. It's an empty vector. So for x in a view of this, for x in v, I'm writing what I'm saying. New items dot push. So we are going to dereference x. So we make changes. So v dot extend. So I'm passing here new items print v. So let's just do this here. So looking at the code again, is this going to compile or not? So here we have a variable created as usual, vector with mute. Then on line 15 we have another variable which owns an empty vector. Okay, now there's no borrow, there's no reference, nothing of such is happening here all the way down. So this is where we get serious. So this is a reference. There's a mutable reference and usage happening here. Then the next line 18. So this piece of data is related to this referencing is related to this piece of data. Then the next line, there's nothing happening to v that is overlapping or breaking the rules. So here we call the new items, call push on it, and then the reference x, which is we look at data on x, we're still looking at it, but also getting the underlying value, like we are using it, we are assessing it. So this is a usage, just like referencing the data and printing it. Usage can be assessing or reading. So we're assessing the underlying value, then adding 100 to each for each iteration. So we add 100 to it and push it to this. So 1 plus 100, 2 plus 100, 3 plus 100, 4 plus 100, and all of them get into this vector. Now what we do next is we are now extending v. We are now extending v by adding the new items to it. So after this is all done, this window is closed, the loop, this window is closed. We come here, something happens where this vector is modified, and look at everything, there's no overlap. So this is where the vector is now assessed. Okay, so if we run this code, we shouldn't have any issues. If we do, we'll try to know why. Okay, you can see 1, 2, 3, 4, 101, 102, 103. So this vector and this vector have been merged. So we are extending v to have this. There is no break of the borrow checker rules. there's no overlap. So let's look at maybe one more example, and then we call it a day. So I'm going to still have this vector. Let me call this, since we call this course, and let's change this 10, 20, 30, 40. Then I'll just score in. So why it's always good to have references when you pass them to functions is because it reduces the chances of breaking the borrow checkers rules. So only pass mutable references when you want to modify the data. But if you're just reading the data and from reading it you want to have other things go on, just read it. So now if so with the reference it again, if score, because we want to access the underlying value, if score is less than 50, okay, let's do 45, 50, 80, 90, 95. Okay, so if score is less than 50, scores the pop. So now looking at this, is this going to compile or not? So here we're creating a variable as usual, and then the next thing we do here, we are reading the values in this vector. So here we check if the underlying value is less than 50, scores.pop. So this is why there's a reading here, there's a modification. So because this pop is taking something out of this vector, modifying this vector, that's an overlap. Okay, that's an overlap. Like I said, this is a reference to this piece of data. While this reference is going on, there's a modification or mutable borrow happening. So this will not work. There's no need putting a print or whatsoever. If we run it, you'd see so immutable borrow occurs here, immutable borrow later used here. Then this is where the mutable borrow occurs here. So cannot borrow scores as mutable because it's already borrowed as immutable. So it's almost the same thing with the push that happened before. So let me just do one more thing that's similar. So let's mute. You can always pause the video to check yourself and be sure if you understand it, and then see if what I'm going to say makes sense. So okay, so going to do another for n in numbers. What should we do? If n is 2, if the value is 2, number is similar to what we did, but this is just a different kind of thing that's going on. So Here we have a variable as usual, a vector, and this is where the borrowing and whatsoever is going on. So the borrow checker is concerned here. Here we are reading the values. We have references to number here, so this should be numbers, yes. So if numbers again, if the value we are reading is equal to 2 with the reference to get the underlying value, then a change is being made here. So this is not going to work because there is an overlap. You are reading this piece of data and modifying it. So what do you want to happen? You're telling me if I go to number 1 College Road, I'm going to find a house, while underneath you are changing what is actually at number 1 College Road. You are demolishing the house. So both of them cannot work. And this is basically everything about the borrow checker. The rules are always, they are concrete. So even when you're using smart pointers or whatsoever, the rules always work. Maybe if it's a runtime thing, it could cause a panic. But if it's a compile time thing, you're going to see errors even before your program compiles. So if it's a problem, your program is not going to compile, you're going to see errors from the compiler to help you fix it. So that's basically what the borrow checker is doing, guiding you, making sure you don't do two things at the same time. It's either this or that, not this and that. Okay, just like enums and struct, it can either be this or that, not this and that. Okay, so that's all for today. I think this video has really been long. I need to stop here, and I hope this has opened your understanding more about how the borrow checker works. So next time you're writing a piece of Rust code, you would know when you might be breaking the rules, or if you see that you're broken the rule, you understand why and how to fix it. Thank you so much if you watch up till this point. I'll be dropping another video next time. I want to share something interesting. I hope you have a great day ahead. Bye.